Just a list of numbers. We've looked at linear sequences before. Today we're looking at something called an arithmetic sequence. And really, they're the same thing. It's a list of numbers that has a common difference or constant rate of change. That means we add or subtract by the same number. It means it's linear. So this is the same as a linear sequence. An example of that would be this. You can see we're going up by 1.1 each time. Something that's not an arithmetic or linear sequence would be this. Here we add 2, add 4, add 8. There's a pattern, but it's not the same, so it's not arithmetic. We can use function notation to represent the terms of a sequence, where the domain is 1, 2, and 3, and so on. In order to do that, to find the first 3 terms of the sequence described by the rule, we simply find a of 1, a of 2, a of 3, which means we plug a 1 in to this equation, get 13. We plug a 2 in to find the second term, and we get 16. To find the third term, we plug a 3 in, and we get 19. We can graph sequences really the same way. Given a function, we can make a table, and from the table we can make a graph. We want to find the first 3 terms. That's why we choose these values for our n. Again, plug them into our function notation. Plugging in a 1, plugging in a 2, 3 times 2 minus 2, plugging in a 3. And then we graph these points. We don't have to connect these points because we can only have a first term, a second term, a third term. There's nothing in between the first and second term, so we don't want to connect these lines and show that there is something in between there. Last thing we can do is write an equation. We can come up with a function rule. So in all arithmetic sequences, in order to find the x term, whatever term you're looking for, you can use this equation or function. F of x equals mx plus b. M stands for the common difference, what you're going up by, and b is the 0 term. This is going to seem familiar to what we've done when we found equations for tables. So our first step is find the common difference. What are we going up by each time? And in this case, it's 2. So automatically, I know my equation begins with 2x. I know my first term is 5, my second term, my third term, fourth term. These are the terms that I know. So I can use my formula, pick one of these values that I know. So maybe I'll choose this 1 and 5. So when I plug in a 1, I should get a 5. So I test it out. 2 times 1 is 2. That means I have to add 3 at the end to get to 5. And this gives us our equation. We also can see that if I work this backwards, 3 is my 0 term, just like the formula states. And you can use either method in order to find the equation. Once we have the equation, in order to find the 17th term, we're looking for f of 17. We're just going to plug a 17 into my equation. 2 times 17 plus 3. So we'll write this. F of 17 equals 37. Let's look at one more. In this problem, my common difference is -4, going down 4 each time. Automatically, my equation starts with -4x. And again, I can look back to find this value at the end. I can find the 0 term, the term that would go before my first term, second term. Or I can use the same pattern that I've done before, where I pick a point, plug in a 2, and try and get to 3. -4 times 2 is -8. I'm supposed to be at 3. Means I have to add 11. In order to find the 10th term, again, we're looking for f of 10. F of 10 equals plugging in a 10 into this equation. Gives me -29.